Welcome to this Pixotope tutorial. In this video, I will walk you through the setup view of the Pixotope Director. At this point, we have already set up a show, linked that show to a project, and configured the machine settings. For more information on any of these steps, please refer to the tutorial video for the Pixotope Director Start View. To start, let's hit Continue on our show to move into Setup View. The Setup view is where you'll handle the initial configuration of your system, including camera tracking and the video routing for your show. The Launch panel lists all of the levels and control panels for the projects linked to your show. Here you can launch levels and control panels in live or editor mode, create new control panels, and you can also push and pull changes to linked projects. The Launch panel is available in both Setup and Production view. In the Show Settings panel, you have the options to edit your project path, import the configuration and calibration settings from another show, and adjust your base settings. The default source settings will automatically populate any new video input or output with the source type, format, and color profile selected here. These can always be adjusted later through the routing panel. Underneath that, we have a couple of engine startup arguments, as well as an option for adding new custom arguments as needed. Now that we've configured our settings specific to the show, we can go ahead and add a camera system. We define a camera system as a video input tethered to a tracking data configuration. Select the Camera Tracking panel and click on Add Camera System and give it a name. You can add additional cameras, but please note that only one camera system can be in use per engine at a given time. Under Camera and Lens, you can specify the film back size using the drop-down menu under Camera Type. The field is also searchable, so you can type directly in here with the name of your make or model. All supplied camera definitions are either 16:9 or 17:9. Their aspect ratio is defined by their film back width and height dimensions. It's important to note that if you do not match the aspect ratios, the output image may be letterboxed or pillarboxed into the output video frame. You can also create your own non-standard aspect ratio by selecting Add Camera Type. Enter your camera type name and then the width and height of the film back in millimeters. Make sure to check the documentation of your camera for the film back size related to the aspect ratio that you'll be shooting in. Next, select the camera tracking protocol. For this example, I'm working with a system that is using the 3D D1 camera tracking protocol. Under Advanced, you have additional parameters for defining the incoming tracking data, for example the assignment of axis and the distance and rotation units. Under Camera Mount, you can select the type of mount setup where not all axes are tracked, for example a PTZ head on a tripod. Here you can apply offsets for height as well as offsets to the camera sensor from the PTZ pivot point. Under Lens Tracking, you can select to enable a lens file and choose between a few of the ones offered in the drop-down by Pixotope. A lens file is a basic lookup table for the lens. While there are templates available, these will never give a perfect result because every lens has unique characteristics even when they are the same make and model. You should therefore ideally generate a lens file for every lens you use. Next, you'll input the zoom and focus encoder limits based on what you see in the Pixotope editor. We'll go over how to get these in more detail in another tutorial. Moving on to the routing panel, this is where you'll define your video inputs and outputs. To add the camera we just created, move your cursor towards the top right. While hovering over the camera system button, you'll see a drop-down of the camera systems created in the tracking panel. Let's select the one we just created. This camera section has been pre-populated with the default video input format and color profile that we defined in our show settings. You can override these settings as needed by using the individual drop-down menus. Under Channel, you can define the input signal type. Fill is the default setting, and it allows you to use the Pixotope internal chroma keyer. Key external key is selected when sending a separate fill and key signal to your system. You'll need to set up a separate media input for the key signal. Fill key external key is selected when the signal is keyed externally and provided as a combined fill and key signal. In the tracking section, you define the transmission settings for your camera tracking system. It's important to note that while the Pixotope tracking service monitors all listed IP addresses, we recommend always setting up your tracking system on a separate dedicated static network to avoid any potential packet loss or delays. The status will update to display the incoming tracking data frequency once successfully connected. Along with the camera system, you can also add additional media inputs if you want to include other untracked video sources in your level. Select Media and then Input. Give the input a name and then select the appropriate source. Let's add an output as well by returning to Media and this time selecting Output. Assign the appropriate output destination, and please note that it's critical for your production that the video input and output frame rates are the same. Fill is used for the internal compositing mode and is the default setting. Key is set for external compositing. Finally, in the routing section, we'll configure the genlock and timecode signals. At the top of the routing panel, you'll find a section called Lock. Here you can select the reference type you are using. Choose External Ref if you're using an independent genlock signal, or select the appropriate SDI spigot if you're locking to your SDI input signal. To add timecode, we once again go up to the top right part of our routing panel and click Timecode. This will then add a timecode section below our genlock section, where you can select the incoming timecode signal. Timecode is not mandatory for a single machine production, but it is a requirement for multi-machine environments. Now to the calibration section. The tracking panel is where you can fine-tune the incoming data and lens data by applying offsets. Below the tracking panel, we have the delays panel. Here you can adjust the delays for each signal in order to match up the tracking data and video input perfectly. You also have the option to apply lens delay independently, which is useful when using a combination of optical and encoder-based tracking. Finally, there's the diagnostics section. In the connections panel, you can measure the response time of your network if you're using a multi-machine setup. The health panel presents useful machine statistics for all of your connected machines, such as GPU and CPU utilization, GPU and CPU temperature, RAM and VRAM usage, and video card temperature. For more information on this or any other Pixotope subject, please visit the Pixotope Help Center, link in the description.